Hello Internet and welcome to this quick video on power, perfect for GCSE science. Now, we can start by saying that power is the rate of energy transfer, or the amount of energy that is transferred per second. And it is also measured in watts, which are generally written as a capital W. There are three equations that you need to learn for power, and you will need to remember these. So the first of these is power, which is obviously measured in watts, equals energy transferred, which might also be written as work done, which is measured in joules, over time, which is always going to be in seconds. This is generally shortened to P equals E over T, or P equals W over T, as these are slightly easier to rearrange. Our next equation is power, again, that's in watts, equals potential difference, which is in volts, times current, which is in amps, or P equals VI. And we finally have power equals current squared times resistance. Again, current is in amps, and resistance is actually written in ohms, and this can be shortened to P equals I squared R. Let's take a look at a few examples of questions. If you'd like to pause the video and give these a go for yourself, please feel free. Otherwise, you could just follow along with me. So here the question is telling us that a device with 14 amps running through it is connected to a 230 volt power supply. Calculate the power. So in this case we are obviously going to be using P equals VI as we have been given our potential difference and our amps in current, and we're going to use these to find out the power. It's really simple, this one. We're just going to substitute our values in, so we're going to have 230 for potential difference and 14 for our amps, and that will be 230 times 14, giving us a power of 3,220 watts. Remember to always write watts after you've got your answer, otherwise you may drop a mark. Here is another example of a question. So this time we have a toaster which has 8 amps running through it, and this time we're given the resistance as well, and it's a resistance of 3 ohms. Ohms may be written as the word ohms, or it may be the omega symbol that you can see over on the right hand side. So this time we're obviously going to be using P equals I squared R, as we have been given amps and resistance, and we're going to just substitute our values in to get P equals 8 squared times 3, which is going to give us P equals 64 times 3, which goes down to 192 watts. And now finally, a slightly more difficult question, as it is a multiple step question, and these are the more likely ones you'll get in a higher paper. We're going to start by saying a 600 watt microwave is used for 5 minutes. How long, in minutes, would a 750 watt microwave to do the same amount of work? So first of all, we are going to use E equals PT, which is just P equals E over T rearranged. So from here we can say that our energy, or the work done, which is what we're looking for, is going to be 600 times 5 times 60. The reason 5 has been times by 60 here is because we need time in seconds, time is given to us in minutes. And what we're doing here is we're working out the energy transferred by our 600 watt microwave. And now from here we can say that T equals 180,000 over 750. Again, this is just this same equation rearranged, except this time we are inputting our energy from the first microwave, and then we are using the watts from the second microwave to put it in the equation T equals W over J, and then we're going to get an answer of 240. And all we have to do here is now divide this by 60, as it's asking us for an answer in minutes, whereas this is seconds. So therefore we get an answer of 4 minutes.